Behavioral assessment of symmetrical building with concrete damage plasticity under seismic load. This paper addresses the response of the irregular reinforced concrete building in planned elevation under a 3-component record of cold earthquake. The nonlinear dynamic time history analysis is developed through finite element method with ABOX. The physical nonlinear behavior of the concrete was represented by CDP involving the plasticity concept with damage. The structure is a simplification of a 4-story building with irregularity in the plan and the elevation disregarding ceiling masonry. In Figure 11, it's notable that the onset of tensile damage is present only at the column's base, and the column's holes zones are critical because the geometric center of the structure does not coincide with the center of rotation. One important point to note in Figure 14 is that the torsional effect becomes evident mainly in the corners columns, due to the asymmetry of the model's construction. Figure 16 shows that the tension of the steel reinforcements from the connection of the last column floor to the structure reach the yield strength values of the steel. The plastic strain in corners reinforcements can be observed in Figure 17 due to the beam columns connection. The results indicate that the building would present a collapse mechanism subject to cold earthquake because all beam columns joints present high levels of damage in the advanced stages of the earthquake. This phenomenon occurs due to the progressive increase of the bending moment along the connections until the maximum bending moment is reached, where the connections lose their strength completely. The structure did not present an acceptable performance to earthquake loads, showing a weak columns and strong beam response. The model used to perform the analysis makes easy the observation of the failure modes and evidence the fragility of the structural elements. Our acknowledgments to Capes and St. Cube.